Okay, so let's dive right in. Today, we're going to talk about a piece of software that has, and I'm not exaggerating here, totally changed the game in modern construction. It's called Autodesk Navisworks, and it's all about catching massive, expensive problems before a single shovel hits the dirt.
Just think about it for a second. You've got this massive, complex project, thousands, maybe millions of parts. How on earth do you make sure a pipe doesn't end up where a giant steel beam is supposed to go? This isn't just a simple puzzle. It's a multi-million-dollar question. Get it wrong, and you're looking at huge delays and a ton of rework.
So, where does this problem even come from? Well, the heart of it is this. Building a single structure involves a whole bunch of different teams. You've got your architects, your structural engineers, and your MEP specialists. That's all the mechanical, electrical, and plumbing folks. And here's the catch. Each one of those teams is using their own special software, creating their own separate digital blueprint.
So here's our game plan for this explainer. We're going to start by really digging into that coordination problem. Then we'll define what Navisworks actually is and see how it hunts for problems. After that, we'll walk through how it works in the real world and finally, look at the bigger picture, what it can do beyond just fixing mistakes. All right, let's kick things off with the big challenge, the very reason a tool like Navisworks needed to be invented. It's basically a classic case of the right hand not knowing what the left hand is doing, except it's all happening in a super high-stakes digital world.
This right here is what we call the silo effect. The architects are over here working in Revit. The steel team is using Tekla. The plumbing and electrical guys are probably in AutoCAD. Now, they're all doing fantastic work in their own worlds, but they're creating these totally separate models, often in different file formats that just don't talk to each other. It's like having critical blueprints all written in different languages.
And this quote just hits the nail on the head. We imagine a building's design as this one big single master file, but that's not how it works at all. It's really a collection, a whole bunch of different specialized models that all have to somehow fit together perfectly in the real world. The whole challenge is making them fit together in the digital world first. So how do you get all those different languages to translate? How do you get those silos to communicate? Well, that's exactly where Navisworks comes into the picture. You can think of it as the universal translator, the one piece of software that unifies all those separate project models.
Now, Navisworks is a huge player in this bigger idea called Building Information Modeling, or BIM. The easiest way to think about BIM is like you're creating a complete digital twin of a building. It's not just a pretty 3D model, it's this shared database of knowledge for the entire project. And Navisworks is one of the most critical tools you use in that whole process.
And this is a really, really important distinction to make. You don't design or create anything in Navisworks. Its entire job is to take all those different models from all those different programs and combine them into one single master model that everyone can review together. We call this a federated model.
It actually comes in a few different flavors. You've got Freedom, which is just a free viewer for anyone to look at the model. Then there's Simulate, which adds some cool tools, including one we'll talk about later. But the top dog, the one with the real magic, is Navisworks Manage. Why? Because it has the game-changing feature, Advanced Clash Detection.
Okay, so let's get to the main event. This is the heart and soul of why Navisworks is just so indispensable on a modern construction site. We're talking about finding those little interferences that turn into massive headaches, long before they get a chance to become real-world problems.
So what is a clash? Well, it's pretty much exactly what it sounds like. It's when a big ventilation duct from the mechanical model tries to run straight through a solid concrete beam from the structural model. It's a digital error that, if you miss it, becomes a very real, very physical, and very expensive impossibility on the job site.
And this right here just lays out the stakes perfectly. Fixing that clash in the digital model might take a designer an hour or two, no big deal. But fixing that same exact clash once the concrete is poured and the ducts are on site, oh man, you're talking demolition, rework, ordering new materials, and weeks of delays. The cost difference isn't just big, it's astronomical.
And this isn't just some abstract idea. This number comes from a real test run on a project. After they combined all the models for the first time and ran an automated test, boom, the software found 40 hard clashes. That's 40 different instances where two solid objects were trying to occupy the exact same space. That's 40 guaranteed show-stopping problems, all found with just a few clicks.
Okay, so we know it finds the problems. But what happens next? How does a team actually take that information and do something with it?
Well, it's a really smart, systematic process that goes from these automated reports all the way to hands-on virtual reviews.
The workflow just makes a ton of sense. First up, you combine all the models. Then you tell the software what to check for, like, hey, check all the plumbing against all the structural steel. Navisworks then spits out this detailed report listing every single conflict it found. From there, you can assign each clash to the person responsible, they go back into their own software to fix it, and then you just run the test again to make sure it's all clear. And here's the proof in the pudding that this process works. Remember those 40 clashes from the first test? Well, after the teams went back and made their adjustments in the design, they ran the test again. The number of problems dropped all the way down to 17. That's a massive reduction in risk. And you just keep repeating the process till that number is as close to zero as you can get it. But, it's not all just about these automated reports. Navisworks is also an incredible tool for just looking around. You can literally do a virtual walkthrough of the entire building before it's built. You can hide a wall or a roof to see what's going on inside. You can slice it open to understand a really complex area or take super precise measurements. It gives the whole team an intuitive way to really understand the project. Now, while clash detection is definitely its claim to fame, the power of Navisworks actually goes even further. It can help teams simulate the entire construction process from start to finish. And this is where things get really cool. It's called 4D simulation. You take your 3D model and you link it to the project schedule. The fourth dimension you see is time. This lets you watch a time-lapse video of your building literally coming together, week by week. You can spot potential logistical jams, figure out the best sequence for your work, and see the whole timeline play out visually before you even break ground. So, when you put it all together, what's the ultimate payoff here? Well, it's huge. It massively cuts down on that expensive rework and those project-killing delays. It makes the job site safer because you can spot hazards in the design phase. It just makes the whole operation more efficient. And, maybe just as important, it gives clients and stakeholders so much more confidence because they can clearly see exactly what they're getting. And that really is the perfect way to think about it, isn't it? That's the ultimate vision that a tool like Navisworks makes possible. It's all about building it perfectly in the computer first, so that when you finally get on site to build it for real, you're not just crossing your fingers and hoping it all works, you already know it will.